The purpose of this video is to put together all the things we've learned about trigonometry so far and get you solving trigonometry problems for the missing sides of right triangles by using your calculator. So we'll start from the very beginning. Back in the 70s, not very many people had a calculator, and calculators were very expensive. So the only way to solve trigonometry problems was by using a trig table. And that's the way that we've been doing it so far. I think it's important for you to see a trig table so that you can see all of the ratios and the angles in one place so that you understand what your calculator is actually doing. So in this example, back from the 70s, we have a right triangle, we have a reference angle, and we know one side. We circle the reference angle. The two sides of the reference angle are the hypotenuse and adjacent, and the remaining side is the opposite. Since we have the adjacent side and the hypotenuse, we'll be using cosine. And we know that in every 62-degree right triangle, the adjacent over the hypotenuse will equal the adjacent over the hypotenuse. In our problem, the adjacent is 25 and the hypotenuse is x. Then we have to go to the trig table. The cosine of 62 degrees. We find the cosine column and we go down to the 62-degree row and we find out that the cosine of 62 degrees is 0.4695. So we take that decimal, which we got from the trig table, and we know that the adjacent over the hypotenuse in any 62-degree right triangle will equal that decimal. So here's our decimal over 1, so that it looks like a fraction, equals our adjacent over hypotenuse, which is 25 over x. So here's our proportion. And this is a part of the problem that caused a lot of difficulties for you last night. When you do the cross product, in this case, you're multiplying 0.4695 times the denominator here, which is x. So that gives us 0.4695x. And when we multiply the other way, we get 25 times 1, which is 25. So now this black equation right here has a number in front of the variable. And as you know, whenever you solve an equation and there's a number in front of the variable, you divide by that number. So we have to divide both sides of our equation by 0.4695. And when we do that, we find out that the hypotenuse of our triangle is 53.25 meters long. When I was in high school back in the 80s, everybody started getting a calculator. They were expensive, they couldn't do very many things, they looked weird, but everybody started to get one. So then we didn't use a trig table as much. Most people used the trig table, which was programmed into their calculator. So we're going to do this problem in that way. So we start out, here's our triangle. Oh no, I left off. It is a right triangle, even though there's no square there. It's a right triangle. We have a reference angle. We know the length of one side, so we can use right triangle trigonometry. Our reference angle is 34. The two sides of our reference angle are the adjacent and the hypotenuse, and the remaining side is the opposite. So our opposite side is where our x is. So we have opposite and hypotenuse. So this is a problem where we're going to use the sine ratio. And we know in every 34-degree right triangle, the opposite over the hypotenuse is going to equal the opposite over the hypotenuse. In our problem, we have an opposite of x, a hypotenuse of 19. So we take this information and we take this information from our calculator. So we have to stop this problem right now, and I need to explain to you one very important thing about your calculator. In math, there's several ways to measure angles. And so far in your math career, you've always measured angles in degrees. We are going to measure angles in degrees on our calculator. But your calculator is made to last you a lifetime. So it is possible to change the mode on your calculator to some other angle measure other than degrees. If you've accidentally pressed some buttons on your calculator and changed the mode so that you are not in degree mode, you will get every problem wrong. So the first thing that we have to learn about our calculator is how to make sure that our calculator is in degree mode. So if you look over here, here's the computer version of the calculator that we normally use in class. And if you look right here on the screen, and if you get out your Casio FX 300ES Plus and you look right here on the screen, there's either going to be a D, an R, or a G. It has to say D. If you're not in degree mode, you will get every problem wrong. So watch carefully as I show you how to put your calculator into degree mode. If you pick it up and you don't see a D right here, you have to press the shift button and then the setup button, and you'll have all of these choices. Well, choice number 3, DEG, stands for degrees. So you hit the number 3 key on your calculator, and now your calculator will be in degree mode. Okay, so we know that we're doing a sine problem, and we know that the opposite over hypotenuse in every 34-degree right triangle will be the same. Instead of looking up the sine column and the 34-degree row to find the decimal value of the opposite divided by the hypotenuse, we're going to use our calculator. So we come over to our calculator and we hit the sine button. And then in the parentheses, we're going to put in 34 degrees. And then you can close the parentheses. Sometimes that's required. Sometimes you don't need to do it. I'm just going to do it. So we have the sine of 34 degrees. We hit equals, and it tells us that the decimal for the opposite over the hypotenuse in every 34-degree right triangle is 0.5591929035. But we're going to round that off to 4 decimal places, just like on the trig table. So that becomes 0.5592. So we take this proportion right here, and we replace the opposite over the hypotenuse with the decimal version of the opposite divided by the hypotenuse in any 34-degree right triangle. So we write a 1 on the bottom. Now here's our proportion. This time the x is on the top. Most students think this is an easier problem. When we find the cross product, 1 times x is x, and 0.5592 times 19 is 10.62 feet. This time we do not need to divide to find the answer because the number that's in front of the x is a 1. So that's why most students think that this problem is an easier problem. Sometime around the year 2000, calculator screens became much more user-friendly so that you could put math symbols and math equations on the screen, and they actually look like they do in textbooks or on your scratch paper. So now we're going to start doing the problem the way that you're going to do the problem on your calculator. So this is different because we started with a trig table. Then we went to just using a trig table that's programmed into your calculator. Now we're going to be able to put the equation on the calculator. The questions that you're going to have to answer after the next 2 examples, they're going to ask you what is the equation and what is the answer for every problem. So make sure that you are paying attention to how to find the equation and how to find the answer. So in this example right here, we have a right triangle, we have a reference angle, and we know one of the sides. So we can use right triangle trigonometry. We circle the reference angle, hypotenuse, adjacent, opposite. So in this problem, we're dealing with an opposite over adjacent problem or a tangent problem. So we know the opposite over adjacent in one triangle, that's a 55-degree right triangle, will equal the opposite over adjacent in every other 55-degree right triangle. So our opposite is 35 and our adjacent is x. So we take this proportion right here and we write it down. And normally we would need to find the decimal value of the tangent of 55, which is one of those decimals that has 4 decimal places on the trig table, or one of the decimals that fills up your whole calculator screen that you need to round off on your calculator. but there's no need for us to recopy that decimal now that we can put the equation on the screen. So instead of finding the decimal value here and writing it here, we're just going to write down tangent 55. So now we have tangent 55 over 1 equals 35 over x. And this problem has an x on the bottom, which is the one that causes most students difficulty because you're going to have to divide at some point to find the answer in this problem. But there's one trick. It's courtesy of the commutative property. The commutative property of multiplication says that you can multiply in any order. So if I'm going to find the cross product here, the cross product is tangent 55 times x. But that is the same thing as x times the tangent of 55. So the courtesy of the commutative property switch is that we can write the proportion like this, or we can write the proportion like this, and it's the same thing. Tangent 55 times x is the same as x times tangent 55. The difference is when we make the switch and we take the numerator from this fraction and the denominator from this fraction and switch places, now we have x over 1 on the left, which is just x, and we have 35 over the tangent of 55 on the bottom. That is our equation. That's going to be what I ask you about at the end of this video. So now we're going to learn how to put that equation into our Casio FX 300 ES Plus. So we don't need to put the left side in. That's just x equals. We only need to find out what this equals as a decimal. So I'm going to hit the fraction button, and on the top, I'm going to put in my 35. And on the bottom, I'm going to put in my tangent 55. And here's where on most calculators, it requires you to close the parenthesis. So there's my equation the way it looks on my paper. And now with these fancy calculators, there's the equation as it looks on the screen. They look exactly the same. So if I press the equal button, I get 24.507. So the answer to this problem for the length of the adjacent side is 24.51 inches. Here's one more example for you to look at before you have to answer some questions on your own. So here's a right triangle. We know the reference angle. We know one of the sides. So we can use this triangle. We can use right triangle trigonometry to solve for the missing side of this triangle. Here's our reference angle. There's the hypotenuse. There's the adjacent. There's the opposite. And so we have the adjacent and the hypotenuse. So this is going to be a cosine problem. So I have the adjacent over the hypotenuse of one 26-degree right triangle will equal the adjacent over the hypotenuse of every 26-degree right triangle. So our adjacent is x, our hypotenuse is 200. So there's our proportion that we're going to use there. Now, we need to find out what the cosine of 26 is. And it is a decimal. It's the same number that we would find on the trig table or the same number that we'd find on our 1980s calculator. But to save us time and trouble and possibly miscopying the number, we're just going to use cosine 26 because we're going to put not the decimal into our calculator, but the equation into our calculator. So instead of having adjacent over hypotenuse equals x over 200, we have cosine 26 over 1 equals x over 200. And the x is on the top. So most students think this is an easier problem because there's going to be no division required. So I'm going to multiply 1 times x, which is x right here. And I'm going to multiply 200 times the cosine of 26, and that's 200 cosine 26. It's really important that you put the 200 in front. If you put the 200 in the parentheses with the 26, your calculator is going to think that you want to take the 26-degree angle and multiply it by 200, which will make an enormous angle, and you don't have an enormous angle, you have a 26-degree angle. So put the length of the side first and then the trig function second. So there's our equation. So when it asks you on the next problem what the equation is, your answer is going to look something like that. And so if we go to our calculator, I'm just going to type in the equation. And I don't need the left-hand part where it has the x equals. I just need to find out what 200 cosine 26 is as a decimal. So I type in 200 and then cosine and then the 26-degree angle. I'm going to close my parentheses. And there's the equation on my paper. There's the equation on my calculator screen. So I hit equals, and it tells me it's 179.758. So my answer for the length of the adjacent side is 179.76 centimeters. All right, here's your first problem that you're going to do yourself. You have a 51-degree right triangle, and you have an x on the hypotenuse. You need to find the equation, and you need to find the answer. On this problem, you have a 58-degree right triangle, and you need to find this side here with the x. You need to find the equation, and you need to find the answer. Here's the last problem. You have a 68-degree right triangle, and you need to find the length of this side right here with the x. You need to find the equation, and you need to find the answer.